Hello. So in this video, I'm going to draw and explain a little bit about a production possibilities frontier. As you can see, I've already set up my axes here, and this is going to be a nation that produces two products, TVs and bicycles. So we're going to draw our line here first. We're going to say it's going to go from 750 to also about 750 on bicycles, and it's going to be curved here, and this line right here is going to show how many TVs and bicycles only, or a combination of the two, this nation can produce. So over here on our y-axis, we can see that this nation can produce 750 TVs if it produces 0 bicycles, so it puts all its effort into producing TVs. Over here on the x-axis, we can see 750 bicycles, the same. The nation can produce that many bicycles if it puts all its resources into doing so. Now, as we follow this curve, we can see how the production of the quantity of TVs and bicycles change as they allocate resources towards one product or the other. Along this curve, so points here, and anywhere along this curve represents a point, a number of outputs of TVs and bicycles that is actually feasible and efficient. So as long as you're on this curve, then you are efficiently using all of your resources to make as many products as possible. Now, if you're inside the curve, like somewhere in here, or say you're making 250 bicycles and 200 TVs, so you'd be around here. This is also feasible for this nation to do, but is not efficient because they are not making the most products they possibly can. Now, if we're out here somewhere, say 750 bicycles and 1,000 TVs, this is not feasible. There's no way that this nation can produce this given this graph, because it's outside of this curve right here, so we know that this is infeasible for this nation to produce. Next, we're going to see what happens if there is a change in say technology or resources or something like that. So let's say that the technology of TVs increased, and this nation can now, because of this, create TVs at a faster rate. So the graph, instead of staying how it is, the end on the y-axis here would curve up. So the graph would end up looking something a little more like this. So as you can see, they can now produce more TVs in the same amount of time as before it would take them to produce less TVs. But as you can see, if you go down to where they were producing no TVs, the amount of bicycles that they would be producing still stays the same, because the technology of a TV increasing has nothing to do with the production of a bicycle. So then, say something happened to where there was a massive recession and a bunch of people got laid off, then our resources would go down of our workers. And so instead of that line there, let me erase this and I'll show you how that would affect our graph. So our workers in both the TV industry and the bicycle industry are both going to go down, because there's going to be layoffs in both companies. So the nation would be able to produce less, so the graph would tend to look something more like this, because production of TVs and bicycles would both go down because you have less people able to make them. So then we can see that now this point is the only feasible point. Although it's still not efficient, it's the only feasible point now that this has happened. So that's my video for the module 1. Bye.